So what we have been doing, reviewing the exponent rules, is we're going to want to start talking about polynomials. Now, we want to think about polynomials. So the first thing we have to look at is terms. And back when we collected like terms, we defined a term as a number. I use the number symbol there as a number, or the product get my writing under control, product of a number and one or more variables. So a term definition, this is the definition we used when we first introduced it, was a number, so 3 is a term, or the product of a number and one or more variables. So 5x is a term, 5x, y, z is a term. Now 5xx is a term because these are products and multiplications that is actually written as 5x squared. So we have x times x in there. And so this is what we want to do with our terms, is we want to get them into a format that we can simplify. And so 5x squared. I said it, but I didn't write it today. There we go. And so this is what we're looking to do, is to get terms written like this. So a polynomial is an expression, an algebraic expression. There, I think I got my pen working again. Written as a term or the sum of terms. With positive exponents. And now, if we remember our quotient rules, positive exponents means there's going to be no variables divided. So you should see no variables downstairs in a polynomial. So, give some examples. Let's give some example colors here. 3x squared plus 2 is a polynomial. We have two terms, right, connected by a sum. And that meets our definition of polynomial. Let me get this up to the top of the screen for you here. So 3x squared is a polynomial because we have a term, we have a sum of that term, and another term. One third x is a polynomial. Because we have a number times a variable, which makes up a term and that fits our definition of polynomial. The thing to note is, yes, there's a division going on here, and this could also be written, you'll sometimes see this written as x over 3. And so yes, there's a division, but the variable is upstairs. It's in the numerator. So this is good. Make it good. Give it a smiley face for a polynomial. 2 divided by x plus 3x squared is not a polynomial. And that's because this x is downstairs. This could also be written as 2x. Let me pull this up again. There we go. 2x to the negative 1 plus 3x squared. And we want positive integer exponents. So if we see divisions, we're not looking at a polynomial. And there are 3 types of polynomials that we look at. Monomial, from mono, meaning 1, has 1 term. And so an example of a monomial is x, y, z to the 4th, right? There's no additions or subtractions, so it's 1 term. Then we have a binomial. Bi, like bicycle, means 2. So you get 2 terms. And so that would be like x, y squared plus 4x. That's a binomial. 2 terms. You have 1 term on one side of the addition sign and 1 on the other. And again, the addition sign is connecting terms. And a trinomial. And again, tri, coming from our Greek, 3 terms, just like a tricycle. And that we get like 4x squared plus 2x plus 5 is a trinomial. Notice none of these terms have the same variable combinations, so they can't be combined into like terms. In the simplest form, these exist. Now, any other collection of terms, if we have 4 terms or 5 terms or 6 terms, we don't keep saying quadnomial or quintinomial. We'll just call it a higher order polynomial or a higher termed polynomial. But most of the patterns we're going to look at involve binomials and trinomials. There are patterns that come out of these polynomials, and it's these patterns that we're going to look for shortcuts to. But what we're going to do is we're going to look at some things we can use to describe the different types of polynomials, their degrees, and the information we get out of them.